Good morning, everyone.
Good morning.
Good morning. Hope everyone doing well. Finally, the sun is out. All right. So as you all know, we sent an announcement on Wednesday that your test is moved from Monday to Wednesday. And today we are going to do the review for chapter 3, as well as I'll go over at least one problem on Bayes' rule. And on Monday, we will have review on chapter 4. And the test is on Wednesday. So anyone has any questions before we start? And I'm going to record the session when we start the review and upload that on Canvas like last time as we did for test 1. If you do not have questions, since we have only 50 minutes, I will start with the Bayes rule, and as soon as I'm done with this, I will start recording the session for the review, and I'll suggest you guys to turn off your cameras when the recording will start. All right, so we talk about, in the last whole class, we talk about conditional probability and Bayes rule. And these are the practice problem that I uploaded on Canvas for you to practice. And we mentioned that you just work on these 4 problems, 1.52, 54, 55, and 56. So I'll go over this one and I'll talk a little bit about this one. And I want you guys to try the 5.5 and 5.6. And as mentioned in the announcement, the solutions of all these 4 problems will be uploaded on Canvas so that you can see if you're doing it the right way or something is not correct, what part you are missing. And again, after looking at the solutions, if you have any questions, something not making sense, feel free to send me an email. All right. So as we know, the Bayes rule talks about conditional probability, or you can say that it is an extension to conditional probability, where we say that probability of any event given under the other event is this. Probability of A intersection B divided with the given probability. So this is what we did in the conditional probability when we are talking about B as an event that is given to us. What happens if this B is a sum of multiple events? Like the example we did in the slide, that what is the probability that the subject has the disease given that the test is positive? And we were looking for the probability of positive test. And when we look for the probability of positive test, it's not just one case. There were 2 cases where the test coming out positive. If you remember, this is the example we did in the slide, that the subjects have either the disease or not a disease. If they have the disease, the test come out to be positive. There is some probability, and negative, and same thing, positive and negative. And when we are looking for the probability of positive test, the test is positive in these 2 cases. So we look at the intersection of disease with the positive and no disease with the positive and add both, then we get this probability. So the denominator is bigger than the numerator, or again, denominator is the sum of the given probabilities, or the given event that is given, the event that is given to you, the sum of those. Similarly, if it says that there is no disease and the tests come out negative. And if we are looking for this, we know that the negative is here and here. So if I'm looking for negative, I'm looking for these 2 probabilities and adding. This is exactly what we are doing in these problems. And here we have 2 branches. One is with the disease, one without disease. There can be 3 branches, 4 branches. And if there are 3 or 4 branches, then you need to look for the conditional probability or the intersection of each. Let's say you get the positive test here, positive here. So you are looking for the sum of this, plus this, plus this, plus this. So again, it depends upon how many events you are working with. So when we say the denominator is the sum of all these. So again, you have to do a little bit work for the denominator. Numerator is not the hard part because numerator, you are just looking for which particular event you are looking for. A intersection B, this is my A, then I'm looking for this. If this is my A, I'm looking for this. So let's do the example that is given to us here in the practice problem. And if you have not started working on your quiz is extended, but it's due tonight. So make sure you work on that quiz. And I want to talk about one question from the quiz also after this. So in 1.52, we said that both bean seeds from supplier A have 85% germination rate, and those from supplier B have 75 germination rate. A seed packaging company purchased 40% of the bean seed from supplier A and 60% from supplier B and mixed it together. So when I read this paragraph, it gives me the information that there are two suppliers, supplier A and B. A seed company purchased seeds from both suppliers, but at the different rate. From supplier A, they purchased only 40%, and supplier B, they purchased 60%. So supplier A seed has 85% germination rate. So out of 100, 85 of the seeds will germinate, and supplier B has 75% germination rate. So this is what is given to us here. In part A, they're saying find the probability of G that a seed selected at random from the mixed seeds will germinate. So in the previous or in this, the background, they said that there are two suppliers, A and B. So let's write it here. There are two suppliers, supplier A and supplier B. Let me do it here. And the company purchased, this is the company purchased seeds from supplier A, 40%. So I converted into decimal, and then 60% from supplier B. Now, if supplier A, you purchase the seed from supplier A, not all of her seed had germination probability. Only 85% of them germinate, and the remaining 15% do not germinate. Let me just check the number here. And if the seeds were purchased from supplier B, only 75% of them germinate, and 25% do not germinate. You can write not germinate or any other thing. I just took the complement germinate and the complement not germinate, the symbol, but you can take any. You can write NG or whatever works better for you. Now the question is asking what is the probability that the seed was purchased from either of the supplier, because the company purchased the seeds from both A and B and mix it. And when the seeds are mixed, we do not know if it is coming from supplier A or it is coming from supplier B. Let's say when the seeds are mixed, we randomly pick one seed. And the question is, what is the probability that this seed will germinate? Because they both have different probability of germination. So now we need to see the probability of germination. The seed will germinate in two cases, here and here, right? Either purchased from supplier A or purchased from supplier B. So what is the probability of germination? So again, when we are looking for the probability of germination, it is A intersection G, this probability, plus, and it is coming from here. So B intersection G. These are the only two ways where we can find the germination probability. And what is A intersection G? It is probability of A times probability that the seed germinate coming from supplier A, multiplication rule for the conditional probability. Same thing, probability of B. And we are talking about this. This is probability of G given B. And this is probability of G given A. And we have these two probability. Probability of A is 40%. Probability of G given A is 85%. Plus probability of B is 60%. And probability of G given B is 75%. Once you have the tree diagram, you have all the information, and when you plug all this information and you solve it, you get 0.79. So the probability of germination is 79%. Similarly, if the question is asking you, what is the probability that the seed will not germinate? You pick the seed from that pile, mixed pile of A and B, and what is the probability or the chance that seed will not germinate? If you have solved this part, then you don't have to solve everything again. You know that the probability of germination and not germination is 1. So you can simply subtract the probability of this. Our fourth rule for the probability of A complement is 1 minus probability of A. You can do that and you find it, because here we are talking about germination, non-germination. Let's say you have not solved this part, then you do the same thing for probability of non-germination. And when you are talking about non-germination, these are the two cases where the seeds will not germinate. So probability of A intersection seed will not germinate. And you do the same way what you did, you will get that. Now, this is the first part. The second part, the question is saying, given that the seed germinate, find the probability that the seed was purchased from the supplier A. So given that the seed germinate, this information is given when you read that. Given that the seeds germinate, so seed germinate, this information we know, and then it says the seed was purchased from supplier A. Now you're solving for this. So when you read the question, you get an idea what is given to you and what you are looking for. So you are looking for this part. And let's write this. Probability of probability of A given G. And when you write it in the conditional probability, we know it's this part. Probability of A intersection G divided by probability of G. And probability of G, we already solved it here, right? So let me just write this here. And if you look for probability of A intersection G, you already solved that also. This is this part. Probability of A intersection G is this. Either you can look from the tree diagram or you see what you have already done. So just write it here. And then you can get the answer. Similarly, if the question is asking, given that the seed germinate and it is purchased from supplier B, you can do the same part here. Probability of G you already calculated. B intersection G, let's go back. We already solved that also. It's this. Or you go to your tree diagram. It's this part. And then you get this. Similarly, if the question is asking, given that the seed will not germinate, you can do that part also. And you get this from here. So 100 minus 79. So basically you are talking about probability of non-germination is 21%. So you plug that here. This one, A intersection G complement. If you look, this is this part. And B intersection G complement is this. And similarly, you can find anything. As long as you understand what is intersection, where is the intersection coming? Intersection is the product of these two. And how? This is our conditional probability rule. A given G is A intersection G divided with the probability of G. And when I multiply these two, I get this part. Similarly, if you are looking for G intersection A and B intersection G, anything, you can just plug in the formula and the given probability goes down. If it's G given A, then A goes down. So this is one thing I want you guys to understand. And look at 1.54. Instead of a tree diagram, a table is given, and you can use this table to work on conditional probability. It says that assume that an insurance company knows the following probabilities related to automobile accident, where the second column refers to the probability that the policyholder at least had one accident during the annual policy period. So here the age of the drivers is given to us 16 to 25, 26 to 50, 51 to 65, and 66 to 90. And the probability of accident and the fractions of companies insured drivers, that information is given. A randomly selected driver from the company's insured driver has an accident. What is the conditional probability that the driver is in the age of 16 to 25? So they said that a randomly selected driver, we don't know which driver, a driver is selected that has an accident. What is the probability that it is from the age of 16 to 25? We can find the probability for any age, like how we did A given G, B given G. So given that the accident was there, and you are looking for that the driver was at the age of 16 to 25. So you need to find the probability of accident happen. And you know that for 16 to 25, this is the probability of the accident times, given that the company's driver is insurance, given that that person had an accident. So this is the probability of an accident when the driver is from the age 16 to 25. And this is the probability or the fraction of insured drivers when they are from different ages. So you can take that as, let's say, let me write, let B denotes the accident, let A denotes the age of the driver, and when you say the age of the driver, A1 is 16 to 25, A2 is 26 to 50, A3 is 51 to 65, and A4 is 60 to 90. And the question is asking you, what is the probability that A1 given B? So first you need to find the probability of B, because when you look for this A1 intersection B, divide with the probability of B. And what is the probability of B? Probability of B is this time this time this. You multiply each and then add. So instead of tree diagram, they give you a table, and from the table you are looking for. So probability of B is 0.05 times 0.10 plus, and you keep on doing, you will find the probability of B, and probability of A intersection B is this already, and then you can find it. And similarly, if you look at 1.55, there, instead of 2 branches, there are 3 branches. One is critical, one is serious, and one is stable. So when you are looking for the combined probability, you are adding 3 things depending upon what information you have. And same thing when you look at 1.56, here also they are talking about different different branches. So look at that and just let us know if you have any questions. So I'll stop this part here and let me start doing the review. And as I mentioned, if you have your camera on, please turn it off. One more thing before I move to chapter 3 review. We discussed this in the class before, but let me talk this again. Let's say I have this table, and let's say this is given to me. If I have this table, I know that I'm talking about discrete probability model because I have individual probabilities. Once I know their individual probabilities of each of the X, I can find their corresponding, once I know how many X's I have, I can find their corresponding probabilities looking at the sample space. And when you look at this probability model, you know that if it's a right probability model to work with or not. Let's say I have this part missing. I have only this. I can find the missing piece here. And we have done problems in homework 4.4, 4.5, where there are a couple of questions where you are looking for the missing probability and then finding the expected value. If it's expected value, average, mean, we are doing the same thing. So there are two questions in 4.4 to 4.5. In one question, it's asking what is the expected value. And in second question, it's asking you the average or mean. Or if it's like this, it's all same. You have information, you have their corresponding probabilities. Sometimes the table is given, it's not hard. You can just plug the numbers and you can find it. When the table is not provided to you, when the question is in the word form or the problem in the wording format, make sure you make the table on the side by taking out the information what is given to you in the word problem. So once you make the table, then it's not hard. You have the table, you can find the missing probability, and then you just multiply and add. That's all you need to do for the expected value. Again, sometimes it's given to you straightforward, sometimes it's not. So you need to make the probability table. Again, I'm talking about discrete here. Let's say if the question is asking you, what is the probability of x greater than 2? Can we find that from this table?
No.
No. So what do you write here?
0.
0, because it is not in the table. But if the question says this, is it still 0? So you are looking for the probability of x greater than equal to 2. So probability of x equals 2 plus probability of x greater than 2. You have the probability of x equals 2 here. So when in discrete, when you have this equal sign plays a role. And as I mentioned, if we talk about continuous distribution, this equal sign will not play a role. If I'm talking about probability of x equals 2 and probability of x greater than 2, and if I'm looking from greater than 2 up till infinity, so this, I don't have any probability here. So it is 0. So when we are talking about continuous and discrete, make sure you understand what actually the question is asking me. In continuous, you are looking for the range because individual probability is 0. But that is not the case in discrete. Also, if this is the table and I'm asking you, what is the probability of x less than 1.2? How can we find that? So I can just go to my table. 1.2 is in between these two. And I don't have the probability of 1.2. But the question is asking me to look for up till 1.2. Let me see, what do I have in my table? I have probability of x equals 0, probability of x equals 1. I don't have the probability of x equals 1.2. So my answer is only this. Because I don't have 1.2, if you write probability of x equals 1.2, you don't have that one. So that is. Or if it's saying probability of x greater than equal to 1.2 or probability of x greater than 1.2, you don't have that. So go to the next one. So for this one, it will be probability of x greater than equal to 1.2. We don't have 1.2 probability. So the next greater than is the only one that I have is this. So there are questions in your homework, in your quiz. And so make sure you understand this concept before working on that. So that was one thing I want to tell you guys. And let's do the review. So let me turn off my camera too. So, okay, let me put on recording as well. I hope it works. Okay, so your test 2, as we discussed, it will be on March 23rd. Let me just double check the date. It's March 24th. March 24th. And you will have 2 chapters, chapter 3 and chapter 4. Testing window. The test will open at 10 o'clock and it will be closed at 4 p.m. So there is a 6-hour window instead of just your class time. And time of the test is 50 minutes plus, as we gave you 10 extra minutes last time. So altogether it's 60 minutes. How many questions? There are 20 questions. And as we discussed earlier in chapter 4, there are more concepts than chapter 3. So there is not exactly 50% distribution of questions from chapter 3 and 4. So chapter 3, let me tell you, you have 9 questions. And from chapter 4, we have 11 questions. And for chapter 3, we use table B, but for the test, you do not need the table B to print out or look at download table B on the side. If there is a question in the test, the line, like how it is given to you in your homework assignments, so line number or line will be given to you, not number, in fact, line is given to you. Line will be provided. And from there, you need to do the simple random sampling. And you can use a 2-sided 3 by 5 inches index card if you want to write your formulas. There are a lot of formulas in chapter 4. So if you want to write it down and that helps you during the test, you can do that. And again, it's closed book and closed notes. So you all sign for academic integrity policy. So make sure do not use those. What else? Did I forget anything? Anyone has any questions? Or if I forgot to mention anything? If not, let's start chapter 3. So chapter 3, we started with the definition of population and sample. And I'm assuming you guys know what a population is, what a sample is. So in this whole chapter, we were working with the sample, and population is basically the entire group of interest. And sample, we are talking about the part of population from which we actually collect information. And then we talk about sampling. And we talk about experiment. So the design of the sample describes the method used to select the sample from the population. So when we do sampling, we started with random sampling. And again, when we are saying random sampling, basically we are using chance to select a sample. We use table B. You can use your calculator, you can use your software, but in the test, you are not allowed to use any software. And as I mentioned, if you are selecting the random sample from the given line, make sure you use that. And we talk about how to do the random sampling using the table. And again, it depends upon what the question is asking us to select the sample. We have done an example in the slide where there were 28 hotels. And in those 28 hotels, the question is asking you to collect a simple random sample of first 4 hotels. So if I'm selecting a first 4 hotels, I label them alphabetically from 01 up till 28. And then I used my line, the provided line, and did the partition after every 2 digits. And then I looked at the first 4. And if some same number is repeated, let's say I had 17 here, 21, and then 17, then I will leave that one because it is already in my sample and keep on going. Let's say if this question is asking me to select 2 samples or to select 2 groups or 3 groups, each of sample of size 4. So if it's asking me to select 2 groups or 3 groups of size 4, so it is the same way. And again, it depends upon what the question is asking you. If you're selecting a 2 group, you can select first group. Let's say it's 7, 21, and next number is 18, and then 4. So that's how I got my first group. And again, I will keep on using the line, and I will make my other group 2, and then group 3. Or I can do that. I can get first sample in group 1, second sample in group 2, third sample in group 3, and keep on doing until I get 4, 4, 4. And again, it depends how the question is asking you to make the groups. The second part, we talk about stratified sampling. And when we are saying stratified, we are talking about stratas or groups. So when we are talking about stratified sampling, classify the population into groups and then choose the simple random sampling from there. So again, classify the population into groups, choose probability sample from each group. That is your stratified. And the next one we talk about is multi-stage. And as the name said, multi-stage, you are talking about various stages before doing the simple random sampling. So we said that stage 1, you make groups, choose the probability sample of the groups, then choose the probability sample of the subgroups, and then you can keep on doing subgroups, and then you can do the simple random sampling from there. Again, it depends upon how many stages you're doing. Stage 2, 3. Stage 1 is your stratified sampling, and you make the groups and then do the simple random sampling. But if you do the groups and then subgroups, and you can do the simple random sampling from here, or subgroup simple random sampling from here, then you are talking about more than one stage, and then you're talking about multi-stage. So there are questions in your test where you have a scenario that is given to you, and you need to read that scenario. You need to tell which sampling design you are working with, which sampling method you are working with. Is it stratified, multi-stage, or simple random sampling? So that is one part. And let me see what else I have. All right. What are the cautions or precautions that you need to do when you conduct a sample survey? So again, there are various methods or various precautions we need to do when we do the sample survey. We discuss the first one. We said that it's under coverage. Then we said non-response. Response bias. Question wording. Sometimes the wording of the question is very confusing and not making sense. The surveyor does not understand what actually the question is asking. Sometimes the order of the question is not right, and that also gives bias in your survey, because if there are confusing questions or leading phrasing, wording of poor wording, order is not in the right form, the respondent will not respond in the appropriate or the correct way. You can say personality bias, or you can say influence response, interviewer influence response, voluntary response. So people have strong opinion. Sometimes only those people respond, not other people feel comfortable in responding in that scenario. So there might be questions where it's asking you what are the cautions you need to do, or if the cautions are given, you need to figure it out which one is that. Is it under coverage? Is this is happening because of under coverage? Response bias, non-response, personality bias. So you can check that. And let's quickly review these three. Under coverage. When we talk about under coverage, so when you are conducting a sample survey, some left out of your sampling frame, or you can say the list from which sample is chosen, then it is called your under coverage. And when we talk about non-response means that you are selected in the sample, but you refuse to answer the questions, or you refuse for the survey. Or let's say you're selected in the sample, but you are not reachable when the survey was conducted. Maybe your phone number is changed, or maybe you're not available at that time. So in when we say non-response, so non-response means those selected, either they refuse to cooperate or cannot be located during the when the survey was conducted. So, non-response and under coverage are two different things. When we are talking about under coverage, you are not selected in the sample. Some, or you can say that some left out of the sampling frame when the sample was chosen. So, when the sample was chosen. But when we are talking about non-response means you were selected. So the sample was taken, but that subject was not approachable, or let's say we said we select a sample of size 50, and then we send the survey by mail to 50 of those subjects. But in return, we got only 30 back. So when we get 30 back, that is suffering from non response, because we send it to 50 selected subjects, but out of 50, only 30 responded back, not 20. Either they did not get the survey in the mail, or they did not have time to send it back, or they did not have time to fill the survey, or they does not have time to send it back. So there are so many other things that when we are talking about non-response, they are selected, but again, they are selected, they are not reachable that time, or they did not respond. That is non-response. And when we talk about response bias is basically inaccurate responses. So you see either you see a pattern of yes no, first question yes, second question no, because I have to fill that survey and I don't have time. I will just do yes no, or all yes or all no. So that is suffering from response bias. So that is about sampling. So let's talk about design, experimental design. So when we are talking about experiments, so we need to know observation study versus experiment. What is observation study and what is experiment? How they are different, how they are simple, how they are similar. So again, when we are saying observation study observe, but you cannot manipulate the response. In experiment, we can observe and we can manipulate the response by applying the treatment to the subjects. So in experiment, we deliberately impose treatment to the subject. And when we impose the treatment to the subject, our goal is to see if there is a cause and effect relationship or not. So when we are talking about experiment, we are applying treatments. And why we are applying treatments, we need to see that when we apply this treatment, does that give me a result? Is there a cause and effect relationship? And again, when we apply the treatment, we compare the effect of those treatment. So we also use placebo effect. And when we are saying placebo, what is placebo? So placebo is you can say that placebo is the effect of dummy treatment. So when we are talking about the response to a dummy treatment, we are talking about placebo effect. We also use another term called double blind. So when we are saying double blind experiment, so double blind experiment, we are saying that we are giving an treatment and we are giving a placebo to the subjects, but neither the subject nor the people who interact with them know who got the treatment and who got the placebo. So which one has the treatment, which subject got the treatment, which subject got the placebo? Neither the subject knows nor the people who interact with them know. Then we call it double blind. So here placebo, in simple word, we can say single blind. That means the subject does not know if they are getting the treatment or the placebo. And when we are talking about double blind, neither the subject nor the people who interact with them, they know who got the subject, who got the placebo. We also discuss available data and anecdotal data. So when we are talking about available data, as the word says available, so that is available to us, which is inexpensive. And again, available to us in the sense that when the data were produced in the past for some other purpose, but it may help us to answer our present question, we say that this is available data. And when we say anecdotal data, as we discussed earlier, it is striking in some way, but again, it is based on individuals' experiences or unusual experiences. So anecdotal data, again, we cannot trust it because it's just based on some personal experiences or unusual experiences, but it's not applicable to a larger data set or larger population. We also talk about a definition or a concept called statistical significance. And I mentioned that statistical significance we will talk about more in chapter 6 and chapter 7. So statistical significance, the definition that we discuss is an observed effect so large that it could rarely occur by chance. Then we are saying that it is statistical significant, and we will talk more about statistical significance in chapter 6 and 7. What should we take, what probability should we consider as statistical significant, or what is statistical significant when we set up a hypothesis, we do the test results. So we do everything in chapter 6 and 7. Here we just talked about that, an observed effect so large that it could rarely occur by chance. So when we say experiment, in the experiment, we use some vocabulary words, subjects, factors, treatment. So subjects, basically experimental units, and factors, we say explanatory variables, and treatment is the experimental conditions that are applied to the to your factors. So when we are talking about treatment, basically the experimental condition that is applied to your experimental units, which is your subjects. So you apply the experimental units to your experimental conditions to the experimental unit. So what treatment you apply to your subjects. We also talked about the principles of experimental design. And when we are saying the principles, we say that first principle is control, second is randomize, and the third is enough subject. So when we say control, what are we controlling here? We are controlling the effect of your lurking variables. And how do we do the lurking variables or confounding variables? How do we do? By applying the treatments and then comparing those treatments. And we discuss what is lurking variable and what is confounding variable and how they are different. So when we are talking about lurking variables are the hidden variables. They are neither in your X or nor in Y, but they are influencing your response variable. When we are talking about confounding variables are called your mixed variables. So when you are looking at the mixed effect on your response variable, so this is your Y and this is your X, and let's say you have another explanatory variable X1 or X2, X3. On Y, you can see that there is a mixed effect and you cannot differentiate, is it just because of my explanatory variable X or my another explanatory variable X1 or my lurking variable, which is not in the picture, but it is affecting. So when you see the mixed effect, then we are talking about confounding variables. So when we have lurking and confounding variables, designs or experiments will help us to control the effect of those variables. How? By applying the treatment and then compare those treatments. So it helps us to control the effect of that. Randomize, again, it's the key when we do the random sampling, how we pick the samples, so randomization, and how do we do the randomization and applying the treatment if we do not have enough subjects, because we do randomize the subjects and then we apply the treatment to the subject to control the effect of lurking and confounding variables. So we need enough subjects to control or to randomize or control the effect of lurking and confounding variables. So randomization and comparison together prevent bias. So randomization and comparison together prevent bias. And what is bias? Systematic favorism. And the last topic that we have, randomized comparative experiments. Randomized comparative experiment. And as the word says, randomized comparative experiment. So we are doing the experiment. So we are applying the treatment. How? We are doing the randomization and then applying the treatment and then compare the treatment. So randomize, apply treatment, and then compare the effect of those treatments. This is randomized comparative experiment. Our first one is completely randomized design. As the word says, completely randomized design. So all subjects are allocated at random among all treatments. So let's say I have 60 subjects and 3 treatments. So I do simple random sampling and select 3 groups. Once I have these 3 groups, then I can apply 1-1-1 treatment to each of the groups, and then I compare. So all subjects, no matter what, all 60 of them will be given a treatment, but we randomize them and then we make a group of 1/3 of that, since we have 3 treatments, and we make 3 groups, and each group will be selected through the simple random sampling, and then you apply the treatment. The second one is randomized block design. And as the word say, block, so you are making blocks or groups or stratas. And how do you make those groups or block? A block, what is actually a block? A block is a group of individuals that are known before the experiment to be similar in some way. So you know that a block before the experiment, and they should be similar in some way, so that it is easy to compare within each block. If they are similar, you will get the treatment result, and then you can compare those. So randomized block design is like you do completely randomized design, but before doing that, you make blocks. So let's say I have 2 blocks. One is, let's say, male and female. And then I have 3 treatments. So I'm doing 1, 2, 3. Treatment, treatment 1, treatment 2, treatment 3. And then I compare. And again, if you look at this is nothing. This is my completely randomized design. Same thing, I do one more completely randomized design. So I'm doing extra step, and that is making the blocks. And blocks, again, you know that ahead of time. So basically, you know before the experiment to be similar in some way, and then you can apply the treatment and then compare. The third one, match pair. And again, as the word says match pair, as soon as you read the scenario, look for the keywords. Does it say same, identical, twins? So when we are talking about match pair, we are saying that match pair is nothing. It is a common form of blocking, comparing just 2 treatments. And when we are saying just 2 treatments, so we are talking about matched pair. What that match pair is, choose two pair of subjects that are closely matched as possible. And how, again, when we are talking about two subjects as closely as possible, so sometimes we say that they are same, they are identical, they are twins, but in reality, it is very hard to find exactly matching pair, but we will try to look for as close as possible. And match pair work with only two treatments. That is the keyword for that. If we are saying two treatment does not mean it is always match pair, but a match pair always work with two treatments. So if you're talking about match pair, two subjects, there is subject one subject, first subject and second subject. First subject will get one treatment, second will get another one, and then compare within a pair. Same thing, another pair, apply treatment one, treatment two, and compare. And let's say one pair has only one subject. That subject will get both treatment, but you order the randomization, or you can say that you randomize the order. If you this subject will get treatment two or treatment one first, and then you compare. So in the match pair design, again, you work with only two treatments. And when we are talking about match pair generally have some keywords when you look at that. And if not, just read, when you read the statement, it will give you what kind of scenario is given to us. Oh, they look like similar. So they are talking about a group and they have only two pair treatments. So first you look for two treatment and then you look for these. If that matches or you have these two things, so you're talking about match pair. And if not, then you can go back and check, is it randomized block design or is it completely randomized design? So I guess that's all we have in chapter 3. And if you guys have any question, let me know. I will stop the recording here. But again, wait a second.
Thank you.
Thank you.
Thank you, guys. I don't know what happened to the recording. I was trying, but it didn't. I don't know. But all right. So I will see you guys on Monday. And if you guys have any questions, just let me know. Have a nice